This video tutorial will look at graphing linear equations that are in slope-intercept form. Slope-intercept form is y equals mx plus b. The number substituted for m represents the slope, and the number substituted for b represents the y-intercept. When given these two pieces of information, we can graph a linear equation. The first example we will graph is y equals 3x plus 2. We always identify the y-intercept first. In this example, the y-intercept is positive 2. It's important to look at the operation sign before the number to determine the value of the number. This is addition, so the value of 2 is positive. Because our y-intercept is 2, we can plot a point on 2 on the y-axis. Now, we will use our slope to find a second point so that we can draw a line to represent y equals 3x plus 2. Slope is represented by rise over run. Our slope is 3. We will write 3 in fraction form to mirror rise over run. So, starting at our y-intercept, which is 2, we will rise 3, then run 1. Let's take a look at how this plays out. We will start by a rise of 3. So from 2, we'll go up 1, up 2, and up 3. Now we will run or go over 1. After going over 1, we now have 2 points that can be connected by our line. So this would be the graph for y equals 3x plus 2. One thing to observe about our graph is that the slope is 3, a positive number, and the line is increasing from left to right. This is consistent with what we saw earlier in our video about slope. Let's take a look at another example, y equals 2x minus 3. Again, when an equation is in slope-intercept form, we always start with the y-intercept, negative 3. So we can plot a point on the coordinate plane on negative 3 on the y-axis. Next, we will look at the slope, which is 2 in this example. Let's write our slope in fraction form, 2 over 1, to mirror rise over run. So we will have a rise of 2 and a run of 1. Let's start from our y-intercept and do a rise of 2. Up 1, and up 2. From there, we will run or go over 1. Once we go over 1, we now have our 2 points that can be used to graph the line to represent y equals 2x minus 3. So this would be the graph for y equals 2x minus 3. Notice again we had a positive slope, positive 2, and our line is increasing from left to right. Let's take a look at a third example, y equals negative 4x plus 1. Again, our equation is already in slope-intercept form, so we can start with the y-intercept, which is positive 1. So we start by plotting a point on the coordinate plane on 1 on the y-axis. Next, we look at our slope, which is negative 4. We will write negative 4 as a fraction to mirror rise over run, so negative 4 over 1. Let's do a rise of negative 4 first. As opposed to our last 2 graphs, where the slope was positive, we went up. But this time our rise is negative, so we are actually going to go down 4. Starting at the y-intercept, we go down 1, down 2, down 3, and down 4. Now we will do a run of 1, over 1. Now we have our 2 points, so we can graph the line. This is the graph of y equals negative 4x plus 1. Notice in this example, the slope was negative and our line is decreasing going from left to right. Let's take a look at another example, y equals 2/3 x minus 3. Because our equation is already in slope-intercept form, we start with the y-intercept, which is negative 3. So we plot a point on negative 3 on the y-axis. Next, we take a look at our slope, which is 2/3. We keep this in fraction format to mirror rise over run. Let's start at the y-intercept with a rise of 2, up 1, up 2. Now, a run of 3, over 1, over 2, over 3. Now we have our 2 points to graph the line. This is the graph of y equals 2/3 x minus 3. Notice our slope is positive and our line is increasing from left to right. Let's take a look at one final example. Y equals negative 3/4 x plus 1. this equation is already in slope-intercept form, so we can start with the y-intercept, which is positive 1. So, plot a point on 1 on the y-axis. From there, we take a look at our slope, which is negative 3/4. Keep this as a fraction to mirror rise over run. Notice we put negative 3 on top and 4 on bottom. Our original slope is negative 3/4. The whole fraction is negative. So that means we have to have one of the numerator or denominator be negative, the other be positive, to make our overall fraction be negative. So we can either have, as shown, negative 3 on top and positive 4 on the bottom, or positive 3 on top and negative 4 on the bottom. Let's use what we currently have to find the second point on our graph so that we can graph the line. Starting at the y-intercept, we will rise 3. Up 1, up 2, up 3. Now, a run of negative 4. Because the number is negative, we will have to go towards the left or towards the negatives. Over 1, over 2, over 3, and over 4. Now we have 2 points to graph the line. So, this would be the graph for the equation y equals negative 3/4 x plus 1. Let's go back and see what would have happened if we would have had negative 3 on top and 4 on the bottom. Starting with a rise of negative 3, we will go down 3 from the y-intercept. Down 1, down 2, down 3. Now, a run of 4. So over 4. This is positive, so we will go towards the positives. Over 1, over 2, over 3, and over 4. Notice this falls on our original line, so no matter what way we looked at our slope, either negative 3 over 4 or 3 over negative 4, we come up with the same line.